Hi, everybody. Mary here. And this time we're going to talk about units that are used to measure energy. And some of these might be incredibly familiar and others not so much. So the four units we're going to talk about are joules, calories, kilocalories, and btus. So here goes. The first one we're going to talk about is the joule. And the joule is the metric unit of work or energy, and it's commonly abbreviated with a capital J. That's the official symbol for the joule. The joule is named for a very important physicist. His name was James Prescott Joule, lived a little over 200 years ago, and he was an English scientist who was the first to demonstrate that heat was a form of energy. Here's James Prescott Joule. He and his family were brewers. They actually made beer for a living. And you have to do something while the little yeast is fermenting the beer. And so he had a laboratory in the brewery, and he did a lot of experiments with proving that potential energy can be converted into kinetic energy, and that he could convert that into a quantity of measurable heat. Now, where might you see joules? Well, one of the places that I have seen joules outside of a scientific laboratory is when I took first aid. When you use a defibrillator, and if you've ever had first aid, you have used one, or at least mock used one, and those defibrillators are charged up to a certain quantity of joules before they can discharge. Another place that you will see joules, and here are kilojoules, is in energy. In the United States, we don't measure food calories or food energy in joules, but in other countries that are more metric than the United States has chosen to be so far, joules or kilojoules is the unit of choice. Speaking of calories, now, the official definition of a calorie is this, and this is an important definition you need to know. A calorie is officially defined as the amount of energy needed to warm 1 gram of water 1 degree Celsius hotter. The definition of a calorie actually comes from a quantity of heat. Now, if you remember, 1 gram of water is the same as 1 milliliter of water. And that is because the metric system is based on the number 10 and water. It was designed that way. So how much is 1 gram of water? Well, it's about the size of 1 bouillon cube, 1 dice. It'll fit into a thimble. And if you could get that 1 degree Celsius hotter, that is 1 calorie. It is not a large quantity of heat, but that is how it is defined. Calories are commonly used in chemistry. Chemists talk about calories all the time. Why? Well, chemists use grams and milliliters all the time, and so calories are a wonderful unit to use in a chemistry laboratory. 1 calorie is equivalent to 4.184 joules. So a joule is actually smaller than a calorie. So there is a simple, and here is a useful conversion between those two. Now, here's one of the things that is very confusing. When you and I refer to food calories, when we say how many calories in that donut, how many calories in that hot fudge sundae, we're talking about food calories, and food calories are kilocalories. Kilo, if you recall, means 1,000. So there are 1,000 heat calories in 1 food calorie, abbreviated a kcal or a kilocalorie. If you look at how many calories are in an amount of food in the United States, you look at packaging, very often it's just going to say calories, and it's not going to indicate that those are kilocalories. How do we get away with it? Well, sometimes in the United States, they deal with it by using a capital C for calories. I find that kind of tricky, but that is the way it is, that when they use that big C for calories, they're meaning kilocalories. In other countries, when they're trying to be a little bit more precise, especially in European countries and countries that use the metric system more fully. On a serving of food, very often they will say how much energy in kilojoules or kilocalories. And here is again per 100 grams in kilojoules or kilocalories. Here is another sultanas. It happens to be a British word that means raisins. And this is calories, and they are listed as energy in kilojoules and in calories, and for 100 grams in kilojoules and kilocalories. Back in the US, they just put a capital C there and call it calories, and we're supposed to know the difference. In this class, I will always label things as food calories or kilocalories to avoid confusion. So how do they find calories? How does a dietitian know how many calories to put on the back of a wrapper of a piece of food? Well, it's a really, really cool process. They use something which is called a calorimeter, and calorimeter basically means calorimeter. Calorie is an old Latin or Greek word that means heat, and metron means to measure. So this is a heat measurer. A fancy calorimeter looks like this. It is a big insulated container. Think of it sort of a little bit smaller than a ice cream maker, well insulated. And inside of it is a smaller container into which you're going to put the food. So if you want to find the calories in, let's say, a hamburger, you put the hamburger in there. Into there, they put a pure oxygen environment. So they saturate it with oxygen. Now, the food that you and I eat is typically made of a combination of carbon and hydrogen molecules. So those carbon and hydrogen hydrocarbon food is then burned or combusted with oxygen. There's a little spark. There's a spark that ignites the process, begins it, is the activation energy. In a typical combustion reaction, out the other end, what do you get? Water vapor, carbon dioxide, and heat. All of this happens inside of a chamber that is totally surrounded with water. And there is a thermometer that measures the change in temperature of the water. Well, there's a simple calculation where the dietitian will look at the thermal properties of water, the mass of the water, and the change in temperature of the water, the mass of the water, and then something called the specific heat of the water. And by multiplying those three numbers together, voila, out they get a number in calories. And amazingly, because the process, the chemical reaction in the human body is so incredibly similar to a combustion reaction, this calorie number is the same number. So I always thought, what a cool job to be a dietitian and determine calories. You burn food all day. They burn a representative sample in a calorimeter, determine calories, average them, and go, that's what a Big Mac is, or that's what a serving of Doritos is. Now a question, how would they do something like a margarita or a serving of 7-Up? Because you can't burn that because they're liquids. So what they do is they dehydrate it. They take off all the water, take the solids that are left, put the solids into the calorimeter, burn that, and voila, out the other end, you have the caloric content. Pretty cool, pretty cool stuff. The average person consumes somewhere in the neighborhood of about 2,000 kilocalories or food calories per day. That, of course, is going to vary with age, size, activity level. If you are a 250-pound man versus a 125-pound person, you need a lot more calories to keep a 250-pound person going than a 125-pound person. You also need more calories to keep a young person going than an older person going. As you age, your metabolism slows down. So here are some typical calorie numbers that will change with age, but of course it will change also with size. If you're 6 foot tall versus 5 foot tall, that's going to have an impact. But as we age, we lose some muscle mass and we need just less calories to keep going, which is kind of a pill I still like to eat, even though I'm a bit older. One of the mathematics of diet and exercise is that you must eliminate 3,500 kilocalories to lose 1 pound of fat. And if you want to visualize a pound of fat is a pound of butter. So that means you need to not eat that 3,500 kilocalories, and yet your body needs to use it up through normal metabolism, or you need to work it off via excess exercise. That additional exercise from walking, from running, from mowing the grass, whatever you're going to do. And this chart is moderately depressing a little bit. So if you eat one lovely cinnamon roll, you have to have an extra hour and 17 minutes of walking or an extra 40 minutes of running. I don't know. Cinnamon rolls are pretty lovely. It's worth it to me, but that's me. One of the things I want you to understand is you can't cheat the math of dieting. All of the fabulous math programs that are out there, diet programs that are out there, that they're trying to sell you this, that, or whatever. Bottom line, if you want to lose a pound, you have to eliminate or burn out of your body 3,500 kilocalories. And counting calories is boring, but as this little guy says, I don't always count calories, but when I do, I consistently get quantifiable and reproducible results. It's boring, but it definitely works. The last energy unit I want to spend just a quick minute on is the British Thermal Unit, abbreviated the BTU. This is similar to a calorie, but it is the English version, kind of like foot compared to meter. This is the English equivalent to a calorie. This is the amount of heat needed to raise 1 pound of water by 1 degree Fahrenheit. Why do I even mention it? Well, I mention it because you're going to see this. If you buy a hot water heater, you buy a propane tank, you are looking at a pellet stove, and you want to know how much heat it's going to give off, very often those numbers are going to be given in BTUs. That is just the unit that's given a lot in heating and cooling systems when you look at those heating and cooling appliances in the US. Next talk, we're going to go into some mathematical conversions between these, but in the meantime, have fun. I was going to say counting calories, but that's never a lot of fun. Have a good time. We'll see you later. Bye-bye.